We often think of AI as these giant, all-knowing chatbots, but the really exciting stuff happening right now, it's on a much smaller scale. AI is becoming like a team of hyper-focused specialists, each with its own kind of magical superpower. Today, we're going to look at two of them, one that can read the unreadable and another that can write the unwritable. Okay, let's get right into it. All right, take a good look at this. I mean, really look. It's warped, it's distorted, it's almost impossible for a human to read. Could you confidently type out what that says? It's a huge challenge, right? This is the kind of messy, real-world stuff that usually just breaks normal software. But what if a machine could read it perfectly? And boom! Just like that, here's the result. In practically no time at all, an AI didn't just read that document, it transcribed it with frankly stunning accuracy. This isn't science fiction, folks. This is the power of a whole new kind of model. So what is this digital wizard? Let me introduce you to our first specialist, Paddle OCR VL1.5. It's an open source model that was built for one reason, to tackle the toughest optical character recognition, that's OCR, and document understanding jobs you can throw at it. It's made to deal with the messy reality of physical paper. Now, here's what's absolutely wild. It's less than 1 billion parameters, which is tiny by today's AI standards, and yet it hits an incredible 94.5% accuracy on benchmarks, outperforming models that are way, way bigger. And it does all this using just 4.4 gigabytes of VRAM. That is some serious punch in a very small package. Okay, so benchmark scores are one thing, but what really matters is how it handles the chaos of the real world. So let's really put its robustness to the test and see what this thing can actually do with the kind of documents you and I see every day. Remember that first document we saw? That's the perfect example. It doesn't matter if a page is warped because it's in a book, or skewed from a bad scan, or if it's just a quick photo you snapped with your phone. Paddle OCR can basically flatten it out digitally and read it like it was a perfect scan. And we're not just talking about printed text. It can handle messy, handwritten notes. It can even figure out when words have been crossed out, understanding the intent behind the edit. I mean, that's an incredibly human-like level of understanding. Now, let's jump to a completely different challenge, math. It doesn't just see the characters in an equation. No, it understands the structure, the fractions, the exponents, all the symbols, and it keeps that complex formatting intact. For scientific and academic work, this is absolutely crucial. And here's where it gets super practical for businesses. It can look at a complicated invoice or a dense data table, see the columns and rows, and pull out all that information into a structured format a computer can actually use. Think of all the manual data entry that just disappears. Okay, so that's what it can do. But the big question is, how does it pull this off? Well, the secret is in this really elegant and super efficient 3-stage pipeline. Think of it like a little assembly line of experts, each with a specific job. So first up, a vision encoder looks at the image. It sees all the pixels and shapes. Then, a large language model decoder acts as the brain, taking all those visuals and understanding what they mean. And finally, a specialized layout analysis module comes in to organize everything, figuring out the document structure and the right way to read it. It's that teamwork that makes it so incredibly powerful. All right, so we've met an AI that reads the physical world. Now, let's completely switch gears and jump into the digital world of software engineering. This is our second specialist, and trust me, it's a master coder. Say hello to SAR 8B. It's an 8 billion parameter coding agent, and it's completely open source. It's designed to automate those really complex software tasks, like fixing bugs, adding new features, or refactoring code, all on its own. So, just how good is it? Well, take a look at this. On SWE-bench, which is a notoriously difficult test for AI coders, SAR 8B scores a massive 31.7%. It's not just a little better. It completely blows past other open-source models its size, and it even beats some much larger base models. Let's just sit with that number for a second. 31.7%. That means it can successfully solve almost a third of real, complex software engineering problems completely by itself. For an 8 billion parameter open source model, that is absolutely state-of-the-art. It's just wow. So what's the secret sauce? How did it get this smart? Well, the answer isn't just feeding it more data. It's about a much, much cleverer way of learning. It's a method they call soft verified generation. And this quote right here is the key. Instead of needing these complicated live testing setups to see if its code actually works, SAR uses a method that lets it learn from pretty much any public code repository out there. That just massively expands its training ground. So check out how this genius loop works. First, a powerful teacher model makes a change to some code. Then it writes a description of that change in plain English, just like a developer would in a pull request. Now here's the clever part. It then tries to perfectly recreate the original code change using only its own description. Finally, it compares the two versions. If they match, great, that's a success. This whole self-correction process lets it generate tons of high-quality training data for itself. Okay, so we've met a document whisperer and a code wizard. They seem like they're from different worlds, right? But they both represent this really powerful and important trend in AI that you need to know about. What we're seeing right now is the rise of the specialist. Instead of one giant model that tries to do everything, we're getting a new wave of smaller, incredibly efficient, and this is the key part, open source AIs that are absolute masters of one specific thing. And this table just lays it all out perfectly. Both models are pretty small, relatively speaking. They each have one key innovation that makes them amazing at their one job. And they're both open source, which means anyone can use them and build on top of them. So why should you care about this? Well, it means the democratization of AI. These powerful tools are no longer locked away in some giant tech company's lab. It means developers can take these specialists and fine-tune them on their own private code to create custom agents. It makes cutting-edge AI way more accessible and affordable for everyone, researchers, small businesses, you name it. And that leaves us with a pretty fascinating question to think about. As these specialized models get better and better, are we actually heading towards a future where AI isn't one single, all-powerful generalist, but instead it's a highly effective, collaborative team of specialists? Something to think about.